Sorting algorithms are generally, you can say, the compared based on their complexity, right? So we discuss, or any, you can say, check that the performance of any algorithm for complexity, right? So there is a concept of space complexity and the time complexity, right? Maybe you guys, some of these guys, you already aware about that time complexity and the space complexity, right? So space complexity is basically how much additional space we require to process, right, that entire algorithm here. Time complexity is how much time it is taking care, it is being taken by the particularly program here, correct? So if you are, let's say, the element is uh, overall loop is basically, or that element into an array is for 10, and if you are iterating 10 times, right, so that you can say the space time complexity will be a on, right? Or n something, because you have iterated, or maybe process is for number of elements, right? If you are iterating, you can say, if you have 10 elements in your array, and if you are relating 10 multiplied by 10, right, it, you will say that it is, if you are using a two for loops, right, so then it will be n multiplied by n or something like that. Then there is a different formulas are there, right? So how you are comparing, and if you are swiping is like that, so in that scenario there is a different mathematical formula you will use it, right, to calculate that time complexity. So generally these complexity, maybe log e formula, generally we use it if you have any divide and conquer some kind of algorithms. So binary search, right, whenever you divide it, you will see, right, log n. So in that scenario, 1 by 2, then again you will divide, then again you will divide is 1 by 2 plus 1 by 4 plus 1 by 8, something like that you will add it. So you can check that formula, that is basically a you will get that, right, exactly log n, right? In that same way, as I told you, right, when you are adding that serial way, if you are processing, right, so in that scenario, og n or on you are taking up, right? So that's the way you can calculate for any particular complexity for any particular algorithm here. So that is one of the most important question as far as that interview is concerned, right? What is that, how to calculate for any complexity for any algorithm? And I can tell you that, right, these algorithms and will be asked till that 9-year experience people also, and can be asked to you 10-year and 12-year experience people also, right? And it can be your life basically, whenever till that time you are into doing the coding. This particularly is one of that most important topic, because the way you write the logic for any particular algorithm, right, that is basically impacting to the performance, impacting to the application. One of the example I can tell you that we were writing that particular code for fetching up that what we can call as some of the tax data. So tax data is in oil and gas industry, people store that some of the sensor information. So there is a different sensors for maintaining that pressures, right? Then also the speed of that particular liquid, then also for temperature and many such things. So in that scenario, or there will be a different sensors, and the census data will be getting stored, got read, and every some particularly interval, and we will store into a one of the system here. And it will not be like completely rdbms like that, but it is a one of the kind of odbc kind of data store here, through which we will connect and we can get it. So in that scenario, there will be some of the main tags, and there will be some child tags. So it could be what we can call as, it is not like a purely a binary tree, but it could be a tree like that, correct? And then you will start reading it, and once you read the data, you will start processing it. And the idea is, the use case was that you need to read the data, and you need to display the data in the form of a graph, right, on that one of the reported here, right? This is one of that industry requirement, right? And or you can also do later into use that predictive analytics. So if the data, if that particular value of that particular tag is from, you can say, for last 3 days for 888, So if this go beyond to 14 or some other configured point here, then there has to be some escalation. And also you can do what we can say, do the predictive analytics. Last 30-day data, you can check it for that one of the tag or one of that sensor, and you can check and expect that what is that another 5 days or 10 days the expected value. Correct. So this is the combined use case when we are talking about where you will use particularly for data structure algorithm. Also you will use a predictive analytics. Also you will also use that how to process the data, and also event driven design as well, right? So many such things will be getting used into one of that critical scenario here. But here we are not talking about all these things for predictive analytics and algorithm, and you can say generating a chart for this data, right? Here we are just focusing on that reading a data and processing it. So when you will get the data, if you are processing it, or if you wanted to search any other tag and get the data, correct? So in that scenario, how you will process the search into this particularly you can say entire data set here. Another example also you can take it up. If you wanted to sort that particularly entire what we can call as the list of employee based on that age here, correct? So you already have, there are some sorting algorithms into a Java, right? So Java is providing that what we can call as the sorting. If you are using that getting the sorted list or sorted map, or if you are using the comparators and many such things, they also use this data, you can say data structure algorithm inside itself. Okay. So basically it is not beyond that or outside of this you can say sorting algorithm. They also use one of the algorithm from this what we can call as from the these sorting algorithms itself, right? So if you wanted to have 50,000 employees and you wanted to sort based on the age, and the age is one of that what we can call as particularly property in your employee object. So you need to write that sorting. So in that scenario, I guess we have discussed already, you can do the sorting based on the comparator, based on the Steam APIs also. But over there also you use the comparator also, and then you will what we can say, then you will sort and you will process it. Correct. So I am not sure about it. They are using a Redis or sorry, is this merge sort or quick sort? But one of the sorting algorithm they use it. So like this, you can check it for that. These how this Java itself internally using a which sorting algorithm, and which is the best sorting algorithm also. Correct. So I told you that any particular time, if you are writing that any program here, if you are doing a sorting, then you can, maybe people can ask to you to write that any other you can say sorting algorithms, or maybe the give that critical scenarios and ask you to a sort, right, without using that Java APIs also. Correct. So some of that, especially I can tell you, like a companies, product based companies, persistent, right? Maybe you heard about the persistent systems. They do any till that 5 year 8 years, they check for a DSA you can say knowledge for that people here, right? And also many such other startups also in fresher levels also and experience, they look for that analytical skills and the different you can say scenario based questions, and check for your DSA knowledge here. Correct. So here we are not talking about too many different, because each and every algorithm it requires a time and we need some discussion here. But I can we can discuss about, there is a two sort here, one for bubble sort and one is for merge sort here, right? So bubble sort algorithm entire tutorial I have already prepared and I put it into our YouTube channel. You guys can go through into a little deep and you can check it, but still I will cover it, right? So I just wanted to understand that how many people are really you can say know about the bubble chart here. Any one person knows that bubble chart? Can you just use the chat box here quickly? So some of the Himanshu is saying Khushbu, the only two people. Anyone else is also aware about that bubble sort here? Quickly, guys, just say yes or no. So let me tell you that the entire concept for your bubble sort here. I will just open the image and you will get some idea. So, so are you guys are able to see my screen here? Everybody, right? So if let's say if you have that particularly given array is for 61853, right? So if you wanted to sort it, so the idea is it is we are comparing from that one of that will the idea is we will take that the largest element and we will shift it to a rightmost corner here. Correct. So in that scenario, we will take up from 6 comparing with the 1, right? If that is the scenario, we will swap it, right? So in first scenario, then it will be once it will swap it, so it will be a 16853. Then again, we will compare with the 6 to 8 here, right? So in that scenario, 6 to 8 is there is a no swap required, correct? In that scenario, again, we will compare 8 to 5 and we will swap it, right? Then once we swap it, then we will compare to 8 to 3. And like this entire algorithm will go like this. So every iteration, 1, 2, 3, 4, 5, right? So these are the number of iteration it is required, correct? If there is a no such iteration is basically, if it is, there is a one thing, correct? So there is a two, three things you need to understand. One is the best case, one is the worst case, and one is the average case. So if the worst case means this entire array got sorted into a reverse order, that highest element into a first, and that like this, right? It will be into a descending order. That is will be the worst case scenario, correct? So you need to understand that what is the worst case scenario time complexity, what is the best case scenario time complexity. Best case scenario means it will be sorted into what we can say into an ascending order, right? Ascending order means uh, it will be already sorted, correct? So still you will compare and you will check it out, right? Because you need to make sure that, so that is the base case scenario. And average case, it could be a, you can say random element, some of the elements are sorted or not be sorted or here and there like this, right? So there will be the base case scenario, average case scenario, and the worst case scenario, right? So comparing that adjacent number and shifting them to a, you can say increase or descending order here. So you need to compare your just adjacent element here. If it is less than, then you need to swap. If it is not less than, then you don't need to swap it here. Like this entire element or entire bubble sort algorithm will work here. So the what we can call as the basic fundamental, you can get the code from everywhere. You can get the code for using the chat gpt also. You can get the code from what we can say geeks for geeks also, and many such different sites you can get it. So code in C++, if you wanted to implement python, java, c sharp, wherever you want to implement, you can get the code, right? So traverse from left and compare the adjacent element, and the higher one is placed at the right side here, right? So the largest element will be moved to the rightmost end, and first then the process is the continue to find the second largest element and place it, so the until the data is sorted here, correct? This is the basically particularly the idea here how you can implement that in entire what we can say the bubble sort here. And if you wanted to get that code also, I can give the site also. You can just get the code directly from here, come into a gigs for gigs, and you can search, you can get the code, copy and paste and try and run it, right? You just need to understand how this algorithm works and how you can write it, right? So you will just come here and then you can just click it for ready-made code also, right? And you can get it into a C++, Java, Python, whatever particularly wanted to, you can get it, you can just use and you can just do it, right? So I will just share that URL also. So this is one of that simplest algorithm which people can understand, and you can use it for sorting, so that at least any point of time, if you want to explain to anyone, you can just use it, right? So that is the one of that simplest one, right? And how to write it, you can, what you can do, you can take a pen and paper and you can start writing the simple steps first, right? So you need that what is the length, right? And you need the array, right? And you can pass it, and you just need one of the temporary variable. So if you are needing a one of the temporary variable, so auxiliary space or your space complexity will be a O1, correct? Because you are looking for only a, what we can say, one of that, what we can call as auxiliary space here, extra space. That's why ON. So that is the particularly what we can call as the entire algorithm, how much time it will take it to compare, and that you are comparing basically, right? So n minus 1 plus n minus something like that, that is the formula we use it, and that it will be the on square here, correct? So this way you can implement it here. You need that two particularly for loop, and then you can compare and you can implement it here, correct? So this is what we can say the simplest one. And you can try and you can write this code into your Eclipse in which particular language you are preferring it. Some of these guys are comfortable with Python, you can write it into a Python. If anyone write it into a Java, you can try writing into a Java. If somebody is writing into a what we can call as into a, any other language, that is this, you can do it, correct? So is easy to understand and simple one, right? It does not require any additional memory space, only one particularly to holding it for one of the temporary variable here, right? And it is a stable sorting algorithm, right? Their element with the same key value maintain their relative order into a sorted output here, correct? So I don't write any such particularly code here as of now in my Eclipse, right? But I have given this is one of the simplest one, so I'm not trying to write into a Eclipse or trying to execute it here. You guys can try, give a taste and trial here. If you are still facing any issues, you can definitely reach out to me. I will help it to you how to write that simple this bubble sort algorithm here, right? But you need to start writing a simple steps from pen and paper, right? And you write it, take the array and length of the array, and start taking up and comparing from the adjacent array here, right? This way you can write it first the steps, then you convert into a program here, okay? So I guess you guys will be you're getting some of the points here. If anybody has any doubt, right, what we can call as related to this algorithm and related to time complexity, related to space complexity, any questions, you guys can just put your questions into chat box. I will help it to you to understand, and I will help it to you for implement. Or still you guys are not able to understand this code and basic things, you can let me know. I will explain the code as well, right? So can you start putting that your questions here quickly? Anybody has any questions here? Hmm? Any questions till now, whatever we have discussed so far? Not yet. Others, anyone else? So if you guys not having a questions, then I presume that you guys are already aware about it, right? And you guys are having a good idea, or you got some idea about it, right? So majorly you need to understand how to create an array, how to process an array, or how to swap it. So swap logic, maybe you can try and you can implement it using a simple swap function, write it into using the simple temp variable, and that is basically you need to understand it, right? And how to process a loop over that particularly array, These two things, if you know that, you can write the algorithm, right? And that is basically you need to do a little bit brainstorming over there if you are getting that what we can call as output or not. And also you can check that the complexity. So what you can say, every time you are take that different data sets. So what kind of data sets? So I'm just putting into a chat here. Let's say if you are taking up the data sets here, so let's say 23, 45, 21, 7, 9, 123. In that scenario, what will be the particularly what we can say the time complexity? If you will have that 12, 14, 16, 36, 67, and 100. What is the time complexity, right? And another scenario, you can take it, it's let's say 140, 130, 87, 65, 43, 23. In that scenario, what will be the time complexity? So you try and calculate the time complexity in these three scenarios, right? If you are able to calculate the time complexity for these scenarios, you will get the idea of your particularly how to calculate that what we can call as, I put it into a chat here, how to calculate, and you can find out that time complexity for a particular program here, and what is the base case, what is the average case, and what is the worst case here. Okay, everybody got this assignment here? So that is you guys can try and you can check it out here. Okay, now let's discuss about that one of that another algorithm which is talk about that merge sort here, right? So